A quiet submarine is hard to find, and it can use its own detection equipment more effectively. An anti-submarine vessel has a better chance of finding a submarine if the noise level of its own machinery is low. There are many machines with rotating parts on every ship and submarine. Every one generates some noise. Many shafts rotate in ball bearings. Any imperfection in the bearings causes vibration, which is transmitted as noise. Since 1952, the Navy has pursued a vigorous noise reduction program. Part of this program has been the reduction of noise caused by ball bearings. Today, the ball bearings used in submarines and in noise-critical machines on ships are noise-tested. They are checked before issue by qualified naval laboratories for compliance with specification noise and dimensional requirements. What is a noise-tested bearing? This is one. It looks like a standard bearing, but if you look closely, you can see the marking NT3. The NT means noise tested. The 3 in this case means the third revision of the specifications for these bearings. Internally, it is much more accurate than a standard bearing. Externally, the diameter tolerances are roughly 1/4 those of a standard bearing. For example, the bore tolerance of this bearing is plus nothing minus 2/10,000ths of an inch. In a standard bearing, it could vary from 4 to 8/10,000ths. Close tolerances pay off in noise reduction. Let's listen to one and compare the noise level to that of a standard bearing. This machine is specially built for measuring bearing noise. A uniform thrust load is placed on the bearing, and the spindle rotated at 1800 RPM. The inner ring and balls rotate while the outer ring is held stationary. A vibration pickup contacts the outer ring of the bearing. Remember the noise level you heard and saw on these dials. Now, we'll carry out the same test using a standard bearing. Most of the vibration in a bearing results from internal inaccuracies and surface roughness. These are reduced to a minimum in a noise-tested bearing. In a perfect bearing, the rings would be perfectly round and smooth, and the balls would be perfect spheres, smooth and identical in size. There would be minimum vibration and noise. In a bearing with imperfections, shown here grossly exaggerated, the balls move at random, which generates vibration and noise. The noise level of the standard bearing is noticeably higher, indicating imperfections of greater magnitude. This increased noise level will contribute to the noise output of the machinery in which it is installed. There are two basic types of noise-tested bearings. Two classes of one type are shown here. The single-row deep groove bearing is designed to support radial loads, but can accept thrust loads in either direction. Note that both shoulders are of equal height. It is made in two widths. This one is standard width. The cartridge width is about 75% wider for the primary purpose of providing additional grease capacity. The angular contact bearing is designed to support higher thrust loads, but in only one direction. On one side, the shoulder is reduced to permit the use of more balls. Manufacturing bearings to tight tolerances is only one element in noise reduction. Another element, just as important, is correct installation. When you have determined that a set of noise-tested bearings needs replacing, approach the task with an attitude of doing a precision job. First, determine the federal stock numbers of the bearings to be replaced. Write the numbers down to be sure you get the correct bearings. The Approved Products List, or APL, shows the correct replacement parts for all machinery on your ship or submarine. If you are replacing angular contact bearings, determine from the technical manual whether they are grease or oil lubricated. All noise-tested bearings should be packaged in a transparent plastic. Leave them in their packing until you're ready to slip them on the shaft. If it becomes necessary to use bearings which have been pre-lubricated with grease in an application requiring oil lubrication, thoroughly remove the grease in hot 2190 TEP oil before mounting the bearings. Before you start, gather all the tools you're going to need. Mark the position of the end bell with respect to the housing, and the end plate with respect to the end bell. Marks should be light and sufficiently distant from mating parts to prevent distortion. Remove the balancing disc. Remove the outer end cap. Also, remove the balancing disc and end cap at the other end of the motor. At each end of the motor, measure the run-out of the shaft with respect to the motor frame to determine if the shaft is straight. Mount an indicator on a fixed position of the motor with the stem pressing against the shaft. Rotate the shaft and note the deflection of the needle, or run-out. Record this run-out on the motor data sheet if you have one. If you don't have one, write it down for comparison with the run-out after the job is completed. Remove the retaining bolts for the inner cap. Then, remove the end bell retaining bolts. Support the shaft to keep it from dropping when you pull out the end bell. And free end bell with jacking screws. Put a packing under the rotor. Slide the rotor off. Use a strap wrench to prevent the rotor from turning as the work proceeds. Remove the bearing lock nut. This type includes a self-locking device. Other installations may involve a separate lock washer, which should also be removed at this time. Be sure to use a bearing puller of the size needed for this particular bearing. Your technical manual will give you the size needed. If the puller attachment fails to contact the inner ring, as in this case, insert an appropriate spacer. And place the puller attachment behind the inner bearing cap. In this way, force will be applied only against the inner ring, thereby preserving the bearing in the existing condition for subsequent failure analysis. Put a soft center on the end of the shaft to keep from damaging it. Hopefully, the bearing breaks loose and comes off easily. We'll show you later what to do if it doesn't. The bearings on the other end come off in the same way. If a bearing is stuck so tightly that the puller can't break it loose, you'll have to grind it off. Removing the bearing without damaging the shaft is of major importance. Do not use a torch to remove the bearing. If you do, you'll damage the shaft. To protect the rotor assembly from abrasive materials, apply a suitable covering. Then, grind through the outer ring in 2 places. After removing the ring, grind through the retainer in 2 places. Then, remove the balls. Grind partially through the inner ring. To avoid damage to the shaft shoulder, make the final cut parallel to the shoulder. Crack it off with a chisel. A seized bearing can result from dimensional mismatch or from overheating, causing fretting or welding between the inner ring and the shaft. In this case, and in every case where shaft damage is noted, measure the shaft as part of the diagnosis of reasons for bearing failure, and to determine the corrective action that is required. Shaft diameters should be measured to 1/10,000th of an inch. For this precision, you must use an indicating type of gauge. If you don't have one, use what you have, even a conventional micrometer. Clean the parts thoroughly, using a solvent or a vapor degreaser where available. move to a clean area if you can. If you don't have one, or cannot move the motor, vacuum or otherwise clean up the area thoroughly. Cleanliness is an absolute must. Put the bearings in their original wrappings into an oven and heat them up to 200 degrees for about half an hour. Usually, the inner bearing cap goes on first. Put on a pair of thermal lint-free gloves. Your fingerprints can cause corrosion of the bearing surface. Take one bearing out of the oven. Cut the packing around the outer circumference. This keeps portions of the packing from falling into the bearing. Slip the hot bearing onto the shaft. And follow it by the lock nut. Tighten the nut until the bearing is firmly against the shaft shoulder, and torque the nut to the required value. For a pair of duplex angular contact bearings, the installation procedure must be modified slightly to ensure that the bearings are properly clamped. Before beginning the installation, consult the technical manual for the correct orientation of the bearings. On one side, the outer ring has a thin or narrow shoulder. This is the face. The opposite side has a thick or wide shoulder. This is the back. In the case of noise-tested duplex angular contact bearings, the parts in some motors are mounted face to face, like this, and in others, back to back, like this. The technical manual will indicate the proper orientation. For the installation procedure, you will need a spacer, a piece of pipe the same width as that of one of the bearings. The faces must be parallel and ground flat. The inner ring of the bearing, being thin, cools very fast when it comes into contact with the cold shaft. The spacer helps you to force it against its shoulder quicker than you could if you used the second bearing. For the first bearing, use the spacer and lock nut to force it against the shoulder. When the bearing cools to room temperature, remove the lock nut and spacer. When preparing to install the second bearing, remember to orient this part correctly with respect to the first bearing, as indicated in the manual. Then install the second bearing and clamp with the lock nut. Torque it to the specified value. After the second bearing has cooled, remove each lock nut. Then, support the rotor on V-blocks at the bearing position. Now check to see that the face of each bearing is perpendicular to the axis of the shaft. Mount a dial indicator onto something solid and place the indicator against the bearing face of the inner ring. Read the dial deflection while rotating the shaft. This runout must be within the tolerances specified in the applicable technical manual. If both bearings pass this inspection, you're ready to reassemble the motor. Remove all burrs and scratches. Clean the mating surfaces of the motor housing. It goes back in the opposite way to which it came apart. Tighten all bolts with a torque wrench. To ensure even tightening, use a criss-cross procedure. Before replacing the end cap, check the squareness of the outer ring of each bearing by mounting an indicator on the shaft with the stem pressing against the face of the outer ring. Rotate the shaft and note the needle deflection. This runout must be within the tolerances specified in the applicable technical manual. Check the shaft runout the same way you did at the start. Compare your reading with that you got before starting the job. Be sure to apply the proper type and quantity of lubricant to the end cap before installation. And torque bolts to the proper value. The balancing disc can now be replaced. And the motor is now ready for shaft balancing and noise testing. The procedures that have been shown apply in general to all bearing replacements. Noise-tested bearings are precision instruments. They cost about 3 to 4 times that of a standard bearing. Good, careful workmanship will ensure years of quiet operation.